Okay. Now, what is on that? What is on? Let me make sure this is even here. What's on the the second video that's there, number 2, just so that we know, just to know that we're on the same page. What do we got? What does it say? Yes. What's on the beginning of that video? Review test forces 2. Is that right? Or test review forces 2? Yes. So just look at the first 10 seconds and what does it say? We're waiting. Not a problem. Craig's on it. Craig's on a mission. What does it say? Okay, so we started friction and gravity. So we talked about forces. We finished forces. Remember the thing with vectors? And that's gone. That's lost. So let me just review very quickly. 5 minutes. Yes? Remember we talked about integers and natural numbers and the Arab culture. Thank an Arab, find an Arab, and thank an Arab. Okay? And that, okay, because they respected knowledge greatly, and Western Europeans did not respect knowledge in any way, shape, or form back in the Middle Ages, the Dark Ages. Okay, one of the reasons it's called the Dark Ages, have you heard that term, Dark Ages? That's a Western term. For the Arabs, that was an age of enlightenment. Dark Ages was European. Don't think that the Arab culture was dark. The Arab culture was enlightened. It's Western Europe that was in the darkness. And that Dark Ages meant learning and knowledge. Yes? Oh, is that where you want to go? I thought you were going to get a book. My apologies. I apologize. I apologize. I apologize. Okay, I apologize. Okay. Yeah. Next time, just go. Tell me. Okay? Thank you. Okay. Next time, you just say where you want to go. I thought that if you need to get a book, that's what I was talking about. Understand? You understand? Yeah. If you have an emergency, you tell me where you want to go. Clear? Everybody got that? Okay, good. Don't ever feel that you have to stay for something like that. Okay, now. Right. So, the whole concept of integers and adding vectors can be traced back to that age where algebra comes from an Arab word. You know, algebra is Arabic. There's other things like zenith, camphor, azimuth. Azimuth is from astronomy and the measurement of stars and the angle above the horizon. That's the azimuth. Okay, so we traced the idea. You know, Western Europe was like Roman numerals, essentially. They could only start at 1, 1, 2, 3. They could count. They could add basic numbers, whole numbers, but no positive or negative. So the whole concept of being able to add vectors can be traced back to that. The concept of integers and the 0 that comes from the Arab culture. Okay, so if I have a vector that's going this way, and that's 8 meters per second, and that's plus, because remember, a velocity is a vector. A vector is magnitude plus direction. This is the direction. This is the magnitude. You get it? Understood? Yes? Yes? Okay. And so if I have another vector going this way, and that's -2, in what direction, and what is the magnitude of the resultant vector? When you combine two vectors, the answer, and here you could argue this. This is actually, you could argue that this is true. Okay. There's only addition. I mean, you could argue that when you combine vectors, it's only addition. Yes? So in other words, it's going to be a positive plus a positive Yes? Or a positive plus a negative, right? Yes? Or it's going to be a negative plus a positive. Yes? You get that? It's always positive. You can argue that. Understood? If you think that way, you'll never, ever, ever make a mistake. Yes? Understood? Okay. So the answer is called the what? What's the answer called? Any ideas? Any guesses? Can you guess? I want 2 guesses. Anybody? Yeah. The net force. I like that. But if we're talking about velocity, net velocity. Right? I like that. That's actually correct. That's not the word I was looking for, but it's correct. So can we say net vector? I like that. Extra credit right there. I like it. I like it a lot. Because when we say, is there a net force? The net force is 0. So that's awesome. Why did you say that? Did you read that in the book? You just thought of that? Kind of one of those weird things that comes up every once in a while and you're like, wow, I thought of that? Yeah, I like that. Cool. Excellent. Well, the word I was looking for, and this is like the official name, okay? I'm trying to be official. This is official talk. I'm talking about vectors, so you got to sound official. So you can't talk about vectors unless you have a deep voice, okay? Do you understand that, Reem? You can't have a high voice, so you got to talk like this when you're talking about vectors, okay? So when you combine 2 or more vectors together, the answer is called the resultant, okay? I'm kidding about the voice. Not about the answer, okay. It's called the resultant. Say that together, resultant. It's a hard word to say. Say it again. Resultant. 1, 2, 3. Resultant. Yeah, it's the resultant, okay? So what is the resultant here? What's the resultant? What's the resultant? Jessica. Say it with authority, girl. You're hedging. You think you're wrong, and if you whisper, maybe you'll be less wrong if you're wrong and less what? Say it with authority, girl. Yes! With one slight error.
No, you say plus.
What? Plus? You need to say plus. Plus 6 meters per second. Yeah, you got to put the unit labels, right? They're called unit labels. People say units short for unit labels. They say, well, what are the units? People say, well, units. But it's really unit labels. Yes? You get it? But you got to put the unit labels. So the answer, the resultant, is going to be plus 6. You get it? Now, if you just put 6 meters per second, would I mark that correct? I'd mark it wrong. If we're talking about vectors and resultant vectors, okay? And the reason I would mark it wrong is this. If I'm testing you on the resultant vector, I want to make sure that you understand that a vector has magnitude and direction. Now, you may have said, well, the plus sign is understood, right? That's what your argument to me is? But you've got to, beyond a reasonable doubt, convince me that you thought that. Couldn't I argue that they did this because they thought that, well, they just need the speed as the answer, right? Couldn't I argue that, well, you put the speed, right? Right? Couldn't I say that? I could be right? Yes or no? Of course. But if you put that, there's no way you meant the speed, right? 100% conclusive that you meant that to be a vector. Yes? The resultant, when you have 2 vectors, the resultant is a vector. So you're adding, this is what you're asking, Chatty. I can hear it from here. It's amazing how loud your brain is. It's wonderful. What you're asking me, well, if it's not a vector, what is it? Right? All right. Can we see over here? Can you see that? Yes? Where does this end? Here? Oh, I got it worse? How's that? Good? Good? Not a lot of room, huh? Good? All right, right here? Okay. When you take, if you don't, give me an example of something that's not a vector, quickly. Speed, right? Right? Mass. Is mass a vector? Yeah, of course it is. Can you have a positive and negative mass? Of course not. You can only have mass, right? Right? The mass of this. It's not negative, okay? It's not a vector, is it? A vector has to have magnitude and direction, right? Mass doesn't, right? So I have 2 grams plus 4 grams, right? The answer is what? 6 grams. That plus sign means you're adding them together, right? So you have 6 grams, right? Correct? Is that a vector? No, it's not a vector. Do we need to put a plus sign there? If you put a plus sign, is it right? If you put a plus sign, is it wrong? Yeah. It would be wrong. Why would you be confused? I said a vector only has magnitude and direction. Didn't I? What you're saying is, I know it's weird. But,
Yeah, I know, because you were saying it like
well, look, watch. You understand about vectors?
Yeah.
Okay, good. So if I say 6 plus 4, okay? Is that better?
Yeah.
That's 6, not plus 6, that's just 6. Okay? That's 4. Not plus 4, just 4. Okay? The answer is 10. Okay? If you put plus 10, you're wrong. Why? Because that's magnitude. How can you have magnitude and direction? Does that make any sense to you whatsoever? Have you guys heard of absolute value yet in math?
Yes.
This is, I apologize. That's my fault. See me after class. Okay? You understand absolute value, right?
Yeah.
Did you ever wonder who cares about absolute value? What's the importance of it? Right? How many people think that? Raise your hand. Okay? Okay. All right. You ready? What I'm talking about now is an application of absolute value. Now you understand absolute value. Does the teacher explain this? Tell the teacher that Mr. Darcy can come in and explain what absolute value is for. Do you understand? These numbers are absolute values. Absolute value. Let's do this. Is that correct?
Yes.
No, it's not. Because there's a plus sign there. Absolute value means what? Yes. No. You're making it too complicated. You're correct. Too complicated. Yes. It's just the magnitude. It's just the magnitude. That's all it means. Yes? I know what Nada was going to say, and I know what you were going to say. You were going to say this. You were going to say that the absolute value is the same number of spaces from 0. Correct? Yes? 3. Correct? Right, but that sounds too complicated. Does it make sense? Does this sound better? Tell me, okay? If it doesn't, say, Mr. Darcy, you're crazy, okay? I get it a lot, trust me, okay? Absolute value is just the magnitude. Is that okay? Yeah?
Yeah.
Right? So for instance, right? The absolute value of -3 is just 3, right?
Yeah.
Okay? The absolute value, watch this. Watch this. Watch this. This is really cool. Okay? All right, watch this graph, right? You ready? You ready? Is that true?
Yeah.
Yeah, because what it's saying is this value here is the same as that value there. This value is the same as that value. In terms of the distance from zero, the magnitude of the distance from zero, right? You get it?
Yeah.
You understand?
Yeah.
Yes or no?
Yes.
Vectors are integers. You understand?
Yeah.
Yeah.
A non-vector is absolute value.
Yeah.
Is there a science word for absolute values? Is there? That's what you're asking yourself, right? Like, how can we put a name to this so I don't have to drag around this entire concept? Like Marley's Ghost drags around the chains. Anybody ever read Marley's Ghost? No, I guess not. No. Sorry. Right? You ready? You know what they call absolute values in science? Like mass is an absolute value, right? One marker. Isn't it an absolute value? Isn't it? Just one. Not plus one, right? Right? So what are absolute values called? They're called this. Scalar. Scalar. Say it.
Scalar.
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 Scalar quantities are absolute values. They're just magnitude. Like, give me some examples. Here, we'll do this on the board. You ready? When did you first learn absolute value? 6th grade or 5th grade or? When? 6th grade? Yes? Okay. So, vector, scalar. Okay? All right. Give me some vector quantities. What's vector? In other words, magnitude and direction. Give me some vector quantities. That we've learned. Give me some examples. Yes? No. No. In other words, concepts. Shall I give you the first one?
Yeah.
Okay. Well, speed is a vector?
No. Direct.
Speed plus direction is velocity.
Oh.
So is speed scalar or a vector? Scalar. Right? Isn't it?
Yeah.
Right? It's not negative or positive, is it? Just size, right? What else? Yes. Distance. Is that scalar or vector?
Oh.
Excellent. Yeah. Excellent. That's going to be scalar. That was very good, by the way. What else? Yes, Nana. What's that? Scalar. What else? Come on, guys. Let's go. Do it. Dig it. Come on. Let's go. Yes. Force is what? Is it vector or scalar? It's vector, right? Right? I pull 5 units. He pulls 2 units.
Yeah.
What happens? It goes which way? 2 this way, 5 this way. You're going to go 3 this way, right?
Yeah.
So you're talking about direction, aren't you? So force is a vector quantity. Yes?
Acceleration.
What's that?
Vector.
You are on fire today.
What?
On fire. You are on fire. Okay. Introduce yourself to the audience. What's your first name? Shout it out.
Zaid.
Zane. Zane.
Z-A-I-D.
I mean Zaid. Zaid.
Z-A-I-D. Zaid.
I said Zaid, right? I said Zane, then I said Zaid.
Yeah.
Okay. Mr. and Mrs. Zaid,
Okay.
your son, you can show the video tonight and say, whoa. Okay? Yes? So, acceleration, yes. What is it? I need a...
Gravity.
Gravity is what? Gravity is, yeah, that's kind of like acceleration, a special kind of acceleration, so we're going to put that. I'm going to put that. I'm going to allow that. The judges say they accept it. Yes, Tara. What is it? Well, free fall is like acceleration, velocity. Friction. Friction is, that's a force. I like that. Friction. Okay, what else? Yes. Well, be careful. There's a lot more scalar quantities than vector quantities, right? Don't you think? Yeah, they're simpler, easier, right? Shall I give you a really good scalar quantity? Really good? Really good? A count. Counts. What's that mean? Like 7 days in a week. So a week. A year. A dozen. Counts. That's a count. Do you understand? Do you ever wonder what a dozen is? Like, what is it? It's a number, but what is it? What is it? It's not a number. I mean, it's a number, but it's something extra, right? Do you ever wonder what it was? It's what? It's a count.
Sir, net force.
What is it?
Net force.
Net force is still, we're talking about vectors. Okay, we can do that. We can go like this. We can put them above and below. We're running out of room down there. Net force. Okay, that pretty much finishes the vector part, right? But, you have things like volume.
No, wait. Wait.
What's weight? Is weight a vector quantity or a scalar quantity? No. Yeah, and we're actually going to explain that today. It's right in the book. We're going to explain that today. Did anybody bring in a scale, bathroom scale? Did I ask you to do that? We're going to talk about that? That's okay. Don't worry about it. Yeah. Okay, so mass. Did I put mass? No. Mass is a scalar quantity. What? Oh, mass is already down there? Well, I wanted to put it again because when people think of mass, they think of weight, right? They're different. When you go to the store and you buy a kilogram of peaches, you think it's weight, right? It's not weight. It's mass. If you buy 10 kilograms of peaches on the moon, right? Right? And they use a scale like they do here. Are you getting more peaches, less peaches, or the same peaches? You're getting more because of mass, because they're calling mass weight, but mass isn't weight. You see? You get it? You get it? Mass is not weight, but yet they're putting it on a balance to weigh it. You get it? Because the gravity's less, right? Don't you need about six times more peaches. Let's say you go to the store and you get a kilogram, right, of peaches, right? Put it on the balance, yes? It says 1 kilogram, right? Well, if the moon is 1/6 the gravity of Earth, how many kilograms of peaches do you need to make it say the same as on Earth? 6 times that, right? Right? So you go and get 6 kilograms of peaches on the moon. If they're going to use a scale, what are they going to give you? They're going to give you 6 kilograms, aren't they? Right? So you tell them you can't do that. You got to be honest, right? Because what they're doing is, that's why students are so confused with mass and weight. In the United States, believe it or not, in the United States, we don't do a lot of metric. Science is all taught in metric. Right, Craig? Yeah. But students aren't as confused as European kids with mass and weight. Why? Because a pound of something is a weight. When you get a scale in the delicatessen, where you get cold cuts like turkey and roast beef, whatever, that's a scale, and that's in pounds.
Yeah.
Right? They don't sell things in kilograms because kilograms is not a weight. You get it? Kilograms is a mass. You get it? Yes? Okay. So, weight. Yes? What's the difference between mass and weight? Yes?
Weight is due to the gravity pulling on.
Exactly. It's due to gravity. It has the gravity, something with gravity. Okay. But let's wrap this up right now, okay? And we're going to stop the video. Okay? We talked about vectors, didn't we? We talked about being able to add and subtract vectors, right? We talked about vectors having two components, direction and magnitude, didn't we? Did we talk about that? And what's a non-vector called? A what? Scalar. And what do you learn in math that's actually scalar quantities? What is it? Absolute values. That's right. Very good. Very good. Ask your math teacher today. Do you have math today?
I had it yesterday.
Well, go find your math teacher and ask them if they know what absolute value really is relative to science.
She teaches science. He teaches science too.
She knows science.
Who's your teacher?
Miss Bat.
Who?
Miss Bat.
Who?
Miss Bat. B-H-A-T-T.
Oh, okay, I got you. Okay. You just yell at me? You did. You shouted at me like I'm impatient. Right? Now, should you be impatient about someone who can't hear?
No, give me how to spell it so I can just get it.
I like that. That was very nice of you, Pat. That was very nice. Chad, that was very nice. Thank you. That helped, actually. Because I don't remember anybody with the name B-A-T.
B-H-A-T-T.
Yeah, B-H-A-T-T. That I know. I never heard it pronounced. But I guess it would be pronounced no other way. But thank you, Chad. That was very nice. You knew exactly why I couldn't hear that, right? You knew that, didn't you? You knew why I was having a problem. I like that. You see that? He knows. He understands why people who can't hear well. I like that. Thank you. Extra credit. Extra credit. We're going to do biology. We're going to do hearing. I like that. I like that a lot. Thank you. That was very nice. So, it's called a scalar quantity, right? Absolute value, okay? So now what I want to talk about is the difference between weight and mass. Weight is a force. This is weight. F sub W is the symbol in physics for weight, F sub W, okay? Shall we quit and then we'll do another one? We'll take a little bit of a break, do some talking, kind of hang out, okay? Yes?